welcome to numerical ship and offshore hydrodynamics. So, today we are going to discuss something called a case study on lower order panel method. So, if you remember in the last class we have discussed hypothetically, I would say in more general way how to solve the radiation problem in infinite fluid domain. However, I see in my class that when actually you are try to code it, then you will find many difficulties. People will find many difficulties. There are several challenges of coding they face, and that actually they do not get the solution so quickly. So, what I decided to take a case study, I take a general body, I mean just particular take a body 3-dimensional body, and then let us discuss how to proceed to write the code, because it is very much expected in this particular course that you end up getting some idea about how to code this problem, because this course is numerical ship hydrodynamics. If you do not code this, then probably you do not get the full flavor of this particular this course. So, what we do is today we are going to discuss, we take a let us take a rectangular barge, I mean that it is not a box, let us take a box type structure and try to find out that added mass in the infinite fluid domain. Okay. And this is the keywords that you are going to use to get this lecture. Okay. So, let us see how we can attack this problem. Okay. Now, you see there is a in any type of coding, actually you have 3 type of thing that you have to find out. The first one is that the first part is how to take the input parameters. How to take input parameters, or what are the inputs basically. Now, the second is the analysis. So, this involves lot of the the geometric thing, it involves lot of geometric calculation, the geometric things that you have to deal with lot of geometry. You need to find out the normal, you need to find out the normal to the body, so many things, discretization, etc., etc. And then how we can do the calculation, and how we can do the calculation, that numerical technique, or like how we can like at the end of the days you have to take the linear system of equation. So, how you can convert the integral equation to the linear system of equation, that is the third part, and of course, then the results. Now, today what we are going to do is we can take, let us say, a box type structure. So, we take a box type structure, and with this idea I mean it is not that very good box. Okay, let us do a better box. Okay. I think this is better. Okay. So, now suppose you have this box type structure, because you assume that is an infinite domain. So, there is no free surface, right. So, you have to mesh the whole box. So, first challenge is how you can mesh this box, right, and how to take the input, right. Okay. So, now here the best way to take the input like in terms of, we can call there is a node with respect to some nodal way. So, you can take in a matrix form. So, first column may be the node, and then you can take some x, y and z, right. So, then this the x, y, z the coordinate of the body. So, let us say node 1. So, there is some x 1, y 1, z 1, then node 2 you have some x 2, y 2, z 2, in that way you are taking it. And then the second one is, this is something called the your geometry file, or you can store the geometry in this matrix form, right. So, it has 4 columns. The first column is node. So, it is 1, 2, 3 etcetera, this is integer, and then you have the real number x, y and z, those all are real number. So, this is the matrix that you are going to take the data, but then you have to have again something called the connectivity. Then what is the meaning of the connectivity? So, connectivity tells you that how these nodes are connected, these points are connected to each other to make a panel. Now, here I just take this is your box, I am just taking one phase out of it. Okay. Let us say this is your box, and then I am taking, let us say, this phase out of this. So, if I write this phase, so this how actually it looks like, let us say this is the phase. Now, you know that in order to do the meshing, definitely you have to have some panels. So, these are the panels. Now, if you remember, when you say the nodal analysis, you are having here that that integer n, and then x, then y, and then z, right. So, then this element have 4 data. One is the your node number, which is integer, and associate this is the x, y, z coordinate. So, now you see here your this rectangle, it connected with this 4 node, and definitely there is 4 node number n 1, n 2, n 3 and n 4, and this 4 node actually makes this panel. So, then you can call this is the panel number I, right. So, it means that you can call this the first index is your panel ID, or you can call the panel number, this is the first index. So, you can take the first panel, so it is 1, and it is connected with, let us say, this node, let us say 1, node 1, node 2, let us say node 3, and then node 4. Now, node 4 sometimes normally where actually people go wrong, they do not know if there is a triangular element, how to make the 4th node. Now, in case of rectangular, you can have some different number 4. However, if it is a triangular panel, let us say this is the triangular panel. So, this is your node number n 1 and it is n 2 and n 3, you do not have the 4th node, right. So, then in that case, let us say it is 1, this is 2 and this is 3. So, in that case the 4th node you can take as 3 only. So, in that way actually you can connect all these panels. So, you can similarly the panel 2, some 6, 7, 8 and let us say 9, in that way it is. So, eventually what you have 2 input files, right, or you can in one input file also you can do that. In first input file you have the node number and corresponding to the geometry. Okay, let me write in bigger way. So, let us do it again. So, in the first file you have node with x, y and z, and then you can connect node 1 some real numbers, node 2 some real number, node 3 some real number, and then you can find out here another geometry which tells you the connectivity. This tells you the connectivity, it tells that your panel number. So, your panel number 1, how it connect to the nodes, which is n 1, n 2, n 3, n 4, all could be different. or there is a possibility that n 1, n 2, then n 3 and n 3. So, that you have to be very particular that okay, if it is triangular panel I can only take it to the right hand side. Now, here is the second questions come, like it is not that easy to say okay, it is fine, it appears it is easy, but actually not. Why I am telling you that when you do the connectivity you have to take care so many things that normally we do not really understand, that this is how and then something go wrong. Like see, the problem here in our domain is little bit it is more difficult, because when your program is not giving results, sometimes we really do not understand it is just because that theorem is wrong, or I interpret the theorem is wrong, or it is the logical error, right. Most if you deal with the data structure and if something wrong you can find over there, maybe it is because of some logical error perhaps, but here your physical understanding may be wrong, your interpretation of the physical understanding to the coding may be wrong, or it may be a logical error. So, you have to be very careful and we can afford any mistake on any point of time. So, when you do the coding, be careful, you are actually doing it rigorously, you are checking every aspect a priori you are writing the original code. And the first point how to do it this, to write this geometry file and read the geometry file in correct way, and then when I say the correct way, what is that correct way, let me explain. Now, most of the time if you look at this the physical problem infinite fluid domain, and let me write the integral equation which is alpha p into phi p is equals to, it is integral, then just it is phi, and let us take, you can call it is del n. Now, we are taking the same thing 1 upon r minus 1 upon r into del phi del n ds. Now, if you remember this, that we discretize as follows, it is summation, let us say I is equal to 1 to n is the total number of panel, then it is phi I, right, and then it is we called it is the functional value, it is del n I of 1 by it is r. Now, it is okay. So, I should make it, let me make it j, or let us say, I mean what I try to say, that when you call that r I j, now here in this case I am taking j as my the field point p and I as my source point q, that you have to understand, like because this summation is over I. So, when you do the summation, it is definitely over the body. So, I is the index for the the surface, and j may be the index for the field point. So, it should be r I j, right, and then you are doing minus, again I just replace by summation I is equal to 1 to n 1 by r I j, and then it is del phi by del n I into, of course, you have to multiply by the area. So, it is d s I, this is also d s I. So, this how we discretize it, if you remember the last class. Now, here the important point is this del I mean n I of 1 upon r is nothing but grad of 1 upon r multiplied by the normal n I, and here all problem comes when you do the numerically. What kind of problem it will come? See here, when I do this analysis, I think this is better box always. Okay. So, you see what I am trying to tell you, that how we define your normal n. Now, here it could be two type. One is either it is outward to the body, which is inward to the fluid, or sometimes which is inward to the body, that means outward to the fluid. Now, you cannot mix up both the things. You have to take either one, either it is outward to the body or inward to the fluid, or it is inward to the body, I mean outer to the fluid, anything. But what is happening when you do the meshing, we forget to take care these things. Why? I am telling you the very, I mean that is exactly related to the connectivity that you are doing. Now, suppose if you take this, okay, and now you randomly you use the connectivity. Okay. Now, suppose if you make a convention is anti-clockwise, this is your convention, then definitely you are getting the normal in this direction. However, but you need to maintain this exactly for all mesh. Now, suppose if you connectivity it is for this particular thing, you make the connectivity in it is counterclockwise this direction, then suppose here if you do the connectivity in the clockwise direction, then the direction of normal over here and the direction of the normal over here will the different. And then when you do this integration, that is grad of 1 upon r dot n, when you do this integration, then you will get the erroneous result. Okay. In fact, if I in this way, if you try to calculate the any component, like I mean here like statically it should be balanced, right, is it not? Now, if you go wrong, then you do not get the total force is 0 without oscillating the body, you should get it, right. Like ideally speaking, if you do not apply anything, then this body does not experience any external force. So, therefore, it should be it should be statically stable in equilibrium condition. Now, if your normal here is outside and if your normal here is inside, and if you do not take care these things, then it is not cancelling out, where if when you do this, maybe the pressure is here and pressure here is same. Now, when you calculate the force, this will get, let us say, positive force, this will also gives you the positive force. So, therefore, your force is not balancing. So, you do not get 0. Similarly, if this is the direction of the normal in this phase, so this phase should be this way, otherwise it will not balance. So, here if this is the direction of the normal in this phase, so that should be the direction of the normal in that phase. Understood? So, this is the basic idea of doing the doing the connectivity. So, you have to understand and you have to really judge before you start writing the original coding. You have to verify that your connectivity is fine and you are getting the normal in uniform direction, either it is inward to the fluid or it is outward to the fluid. Normally, what we do is, normally we take the normal is outward to the fluid and inward, I mean sorry, inward to the fluid, outward to the body. So, normally we define the normal in, it is inward to the fluid. You see this body is surrounded by the fluid only in infinite domain. So, therefore, we are considering it is inward to the fluid, not outward. So, understand. So, this is the something that you need to take care when you even start writing the original code. We are not even started the code, right. Here we are just discussing that we are not doing anything wrong when we start I mean read the geometry and interpret the geometry, because this is the most important part that we are going to do, right. So, when you are done with this, Now, suppose your connectivity is fine. So, and that you have to check manually, there is no other way to check. Like one way to check that you can make the pressure to be constant, you just you can let us take that you simply do that, you know, that n I dot d s I, you just sum it up in that in all distance, and if you do that, then you should get that equal to 0. This is the check, right. So, what I said that if you do the paneling, you know this area of the panel, let us say, and then you simply multiply this area with the normal vector n I, and you just sum. Now, if your normal is correct, then you should get it is equals to 0. If it is not equal to 0, then you have problem. Okay. Fine. So, let us go ahead, let us go ahead next. So, now we understand that we read the geometry accurately, right. Then what you need to do, that you need to define some panel property. Now, when I say the panel property, the panel is, you know, each panel what type of property. Now, here actually we can make some difference between two type of coding, something based on the object oriented coding, right, like C, C++, C sharp, I mean not C plus C, C++, C sharp, Java. So, somebody is doing the object oriented programming, oops, we can say, and somebody using the MATLAB code, which is not really I do not know is object oriented or not, but here you know you can define the object if you are going in C or in a C++ or let us say C sharp, you can make your own structure. So, let us discuss the both. Now, you have to define some, you can define in case of you are doing let us say C sharp. So, you can define some object as panel. Now, in this panel object, what is the thing you need to do? Now, remember this formulation, which is summation, which is del n of 1 upon r multiplied by the, you know, dsi, right. You have to remember this one, right. So, then I understand in this panel it must have, and then if it is a lower order panel method, you have to know what is the centroid. So, this panel better to have the information about the 4 corner. So, the 4 coordinate. So, you can define another object here as point, right, and this in object point you can have only this double x double y and double z. So, this is your structure of the panel, right. Okay. So, now here in panel you can take the list of point. Number 2 is the CG that you can calculate from the list of point. Third one is the panel normal, and then fourth one is the what more is left, it is the panel area. You know, if you have these 3 things, probably you really do not need the list of point, right. But however, it is better to have this with you. So, now the next thing that you are going to do is that you are going to define a object which is called the panel, and in this object you are putting all these values. However, if you are doing a MATLAB coding, sorry, if you are doing a MATLAB coding, if you are doing the MATLAB coding, you cannot define a object like panel. So, in that way you can define some vector, right. In this vector that you can define some vector and that vector you can use as the many columns. So, in that vector let us say some you can define some vector v, and this vector also, in this vector you can store all these property like that coordinate the x and also the area A, the normal, the 3 component of the normal, and also the centroid C g. So, you have to remember that you can define all these vectors in case of a MATLAB coding, but however, in case of a if you do the object oriented coding, then you can actually define a object panel, and in this panel you can define all these particular thing, right. So, now here also the both the thing. So, in case of a the object oriented trace programming, you can define some concept of point, and then you can define some concept of the vector, that is the object you can create. Also you can create the some concept of panels, right, and inside the panel you can define the list of point you can take, which is the 4 corner point. Also the CG or centroid again is a point, and also then you can call the a double, which is area, that means area of the panel, and also you can define a vector which is the panel normal. That you have to, now this you need to get through your geometric data that you have stored, right. So, how to do this? How to get this that CG, area, panel normal, everything, maybe we can we can discuss in later classes. Okay. And in case of a MATLAB, they can define a vector for points like x, some arrays, and then you can define some y of some array, they define the z of some array, they can define this area some array, they can define the normal, this is some normal, this is also a vector, and then can define the CG also with a vector. So, today actually then we discuss that how to take care about the geometry, and then how to structurally how to do this the basic parameters you are going to set. Now, still we are not attacking the original problem, right, we are not yet solving the problem, that we are going to discuss in the next class. Okay. So, for today we understand. So, now this is a case study. So, you can call this a case study for finding out the radiation problem of a box type structure in finite fluid domain. Okay. Fine. So, in the next class I am going to discuss how we can get the normal from given geometry, and then how to get the CG, the area, and how to integrate the things, how we can make the matrix, all these things we are going to discuss in the next class. Okay. So, till this point, thank you.